Hello. All right. Audio's good, music's good, and game is up. Sweet. All right. So today we are going to be working on trying to get the directional lighting to work. Well, not directional lighting, directional sprites. And I finally found a tutorial for it. This one's actually from Unreal University. It's how to make do-style directional sprites. So we'll be following that today and trying to get the change to be right. Oh, I also talked about this last stream. So the hook for my game, I think I figured it out. I think I'm gonna, like, the hook is gonna be, Doom-style gameplay, but fantasy city builder. So I think it's kind of like, there's like this game that came out, like Cult of the Lambs or something. I've only seen a little bit of it, but I think it's like a similar concept, and it seems to be doing really well. But yeah, I've been wanting to do this for a while, so let's get to it.
Idle underscore.
Reset.
Hello. In this video, I'm gonna go over how you can set up an 8-directional sprite, like in the classic.
We're only gonna do 4 directional. Well, maybe 5 directional. So side, side, and top is what I want.
I'm gonna have some files in my project, so mine may look slightly different to yours, but you can ignore those. And if you want to follow along, I'm gonna include this image of this enemy sprite, which I'm gonna use in this tutorial video. A link to find this will be in the description of this video. If you do use it, when you import it, just right click on it and go sprite actions and apply paper to the texture settings. That way it looks smooth. So what I did is right and front right. So just make sure you create sprites for all of them and make sure that you name them accordingly. That way when we reference them it'll be easier. And then once you've done all that, just go create a new blueprint class and select character, because I make this an enemy in my game. Then I just call this the base enemy underscore blueprint. Then we can head inside here and we're ready to start. If we go over to components and go add and look for a paper flipbook. For the paper flipbook, select the flamethrower idle underscore F flipbook that we made earlier. And currently right now, this is not facing the correct direction. If I just select this arrow component, this will let me know the forward direction of our base enemy blueprint. And currently right now, we can see the paper flipbook is not facing forward. So we want to make it face forward. To do that, we can just select the paper flipbook and go over to select and rotate objects and just rotate it 90 degrees in the x-axis. Now it's kind of small and doesn't fit the capsule. So with this little scale icon checked, let's increase the scale of our paper flipbook. I'm going to make it say 3.5 in all its units, and I think that is looking a bit better. So the idea here is we have 8 different flipbooks for our enemy, and depending on where the player character is positioned and where the enemy is positioned, we're going to play a different flipbook. So if say I'm in front of the enemy, then we're going to play this front facing flipbook. But if say I am behind the enemy, don't copy this bit, we're going to play the enemy back flipbook. So this is how I'd see the enemy if I was behind it. So let's set up that system. To do that, we can go over to the event graph. Interesting. And we're going to hook this up to
excuse me. Okay, so he only uses one sprite book. Interesting. Okay, I'm gonna make a duplicate of him before I edit stuff. Slimy boy. There we go. Duplicate. Slime 1. Slime underscore enemy. Let's try to keep like an actual naming convention here. Okay. So I'm gonna go delete the side view one. Delete. Here. This anymore. So delete. Reconnect. That should be good. Phone's gonna be vibrating a bunch. Someone's trying to like set up like a meeting with me. Just go over here. Silence.
Event tick. So event tick, which will run every single frame, we're going to make sure that the enemy is showing us correct paper flipbook. In order to do that, we're going to get the player character's location and the enemy's location. So if we just right click and look for get player character, and from here we can just drag off and look for get actor location. And then if we just right click and look for get actor location, this will just get the location of our base enemy blueprint. And we just want to drag off here and look for subtract. And we just want to subtract these two values. Then we just want to drag off here and look for normalize. And what this normalize node will do is get the unit direction of these values. So this will basically allow us to know if the enemy is in front of us or behind us. Just so that you can see what I mean, I'm just going to drag off event tick and look for print string and connect this into here. Then, to help showcase this example, if you go over to the viewport and go add and look for an arrow, and for the details, look for hidden in game and just leave this unchecked. And now I'll go compile and save, and I close this and I go play. So when I'm in front of the enemy, we can see the value in
How do they get it to do that? Showing the
into here. Then
there we go. Okay, so over here real quick. Okay. And let's pull. Let's get rid of you. And let's pull in a slime enemy dude. Cool. Okay, still follows. That's good. Oh yeah, I forgot I increased the speed so I could test the open world. Whoosh. Ideally, this is gonna be closer to the actual character's speed in the game. Whew. Definitely needs gonna be like a. Oh gosh, here I go. Okay. Okay. Yeah, really fast combat. Just jump. Okay, I don't know if I show this off. I'm also made a torch. Gonna need to fix that so it doesn't do that. I am worried though that that many updates is gonna slow down the game. That's a lot of notifications to be getting.
To help showcase this example, if you go over to the viewport and go add and look for an arrow, and for the details, look for hidden tip. It's just right click and look for get actor forward vector.
Okay, so get rid of this. Uh-oh. Okay, no.
And then we just want to drag up here and look for dot product and connect this into here. And look for get actor forward vector. And then we just want to drag up here and look for dot product and connect this into here. So I'm now gonna kind of
Whoa. Don't know what I just did there, but looks like I just ran it.
what the dot product node does. It's kind of a bit complex, but I'm gonna explain how it kind of works. Okay, so the dot product takes in two vector values. I'm going to use an example to showcase how it works. Imagine each vector in the dot product as a car. Now each car has a direction that it's facing. Now we want to find out how much the two cars are facing the same way. To do that, we use the dot product. To find the dot product, we take the first car's vector and multiply it by the second.
Oh, gross, he's saying math.
We add all of those numbers together, and that gives us a single number. That number tells us how much the two cars are facing the same way. If the number is big, then the cars are facing almost the same way. If the number is small, then the cars are facing different ways. So that's how the dot product node works. Next, if we just drag off the dot product and look for acos degrees, this will kind of convert the dot product into some degrees, and we're basically going to use this value to help us determine what flipbook we should play depending on the forward vector of the enemy and the location of the player character and the enemy. If you just right click on this and promote it to a variable and just call this degrees, and just connect this into event tick. After we've done this, we're gonna just right click and look for get actor right vector, and then we just want to drag off this normalize and look for dot product and just connect.
Alright, slow down there, everybody. Faster. So, get actor rate vector, and then dot product.
Put this into the bottom one and this into the top one.
Gosh dang it. Bottom. Top. There we go.
And then if you just drag up here and look for less than and just leave this at 0, and then drag up here and look for branch.
Hold on. So less than to branch it.
And connect this into here. So by doing this little calculation, we're basically going to be able to determine if the player character is on the right or left of an enemy. If this
Turn the music down real quick. That is a bit too loud.
is true, that means we're on the right side of the enemy. If this is false, that means we're on the left side of the enemy. And then this will let us know how many degrees centered we are to the enemy. And by using these two calculations, we're basically going to be able to determine what flipbook we should play for our enemy depending where the player character is. I'm just going to drag off here and look for print string and connect this into here. And I'm just going to click this little arrow here and make the color of this print string, let's say green. Then I'm also just going to drag up here again and look for print string, and we can connect this into here. And I'm just going to click compile and play this just so that you can visually see what I mean. So it's print stringing true because I'm on the right side of the enemy, and we can see I'm about 88 degrees to the enemy. If say I go to the left side, then it's going to print string false, and we can see I'm about 128 degrees to the enemy. So by doing these calculations, we're going to be able to determine what side of the enemy we're on and how many degrees we're facing, and this will allow us to determine what flipbook we should play for our enemy. Okay, so we can now delete these two print strings and connect this into here. Off of the true, I want you to drag and look for the compare float node. So we want this one, compare float, and this will basically compare the value of this input with the value here. For the input, we just want to drag in the degrees variable that we made earlier and look for get degrees and connect this into here. And for this first one, we want to compare it with the number 180. If this value is less than 180, then we just want to drag up here and look for compare float. And this time we want to compare it with the number 135. Again, we want to copy this degrees.
Okay. This is where we're gonna have to start customizing it because I'm not doing a. What does he say? Like this is an 8 style directional. I only need 4.
And connect this into here. I'm gonna copy these nodes again and paste them here. And this time we want to compare it with the number 90. Then we're gonna copy this one last time. And this time we want to compare it with the number 45.
Okay. needs 4. This is 4 directional. Just keep watching and see.
We just want to copy all of these nodes. And we want to do the same thing for the false, so just connect that into here. Next, so depending on the degrees and the number, we're basically going to make the paper flipbook play a certain flipbook, so we may make it play the forwards, backwards, forward right, or forward left. Before setting the flipbook, we basically need to set the rotation of our flipbook, otherwise it won't look correct. To showcase what I mean, I'm going to go over to the viewport, and let's say I just select my paper flipbook and change this to be the flamethrower idle underscore left. The arrow basically lets me know the forward direction of this enemy, and currently we can see it's not facing the correct direction. If say I was towards the left, so the player was facing the left of the enemy, this is how it would look, and it looks kind of weird. So we need to make sure that the flipbook is kind of rotated, say let's say
interesting.
180 degrees in the z-axis. That way when the player character views the enemy from the left, they're looking at the enemy with the correct flipbook and it looks all normal and correct. So before we change the flipbook of our enemy, we're going to actually change its rotation so that we can view it correctly. If you go over to the event graph, I've already made all the calculations for what angle we need to view each sprite at.
Okay, so 180 is what's a calculator? Can you? TI 84. Okay, so I can figure out why he's doing that. So that was times, my bad. 45 plus 45. Okay, so if he wants 1, 2, 3, 4. Okay, so 180. So this should be 90. I'm just doing the 2. Then you take them. Reason there. C, B, connected to the bottom. Like that.
So to get started, in some free space, just drag in the paper flipbook and just drag up here and look for set relative rotation.
Okay, I'm gonna recall this Sprite paper book. There we go. So rename that. Pull it in. It was set relative rotation. This is. Oh, this is gonna be a lot harder than I wanted it to be. Okay.
Then for this first one,
Unless. What if instead instead of doing a tree-like substance like this, going, change the flip book, change the rotation. What if I just had 2 flip books and turn them on and off? So if it's like, if it's this. Greater than if it's. Yeah, we can experiment with that in a bit.
in the Z, put a value of -90, and just drag up here and look for print string. and just make this say front. So when we are viewing our enemy from the front, we're basically going to make it have a rotation of -90 degrees. And we're also going to set it so the flipbook is playing the front flipbook animation. Whilst we're here, we're going to set up our flipbook system. If you just go create new variables and just call this flipbooks, and here under variable type, if you look for flipbooks and select paper flipbook and select object reference. Then if you click this little button here and just change this to be an array, by making it an array, that basically means this variable can hold multiple values. Just go compile and add 8 array elements. Copy this in the order that I'm doing this. For the first one, we want this to be the flamethrower idle underscore F. Then we want the flamethrower.
So first one is
idle underscore FR. Then we want the flamethrower idle underscore left.
oh right. I don't have a back idle. Okay. Let's just throw in that just to make sure. Just have something to see.
Then we want the flamethrower idle underscore back left. I kind of misspelled mine. Then we want the flamethrower idle underscore back. Then we want the flamethrower back right. Then we want the flamethrower right. And then we want the flamethrower front left. And I'm actually just going to rename this and call this flipbooks idle. So these are all the idle animations.
Oh boy, okay. Okay, so first off, I think we're just gonna have to re-import the slime guy entirely. So let me get skill going. I'm gonna need to make some animations. Okay. Oop. There we go. Okay. So we got forward. Okay. Okay, yeah, so that's its forward movement. Its hit. That's death. Wish I could name these. Okay. So we need to go duplicate, move down here, duplicate, move down here. This one should be relatively easy. Just remove the eyes. And then we're going to take this color, make it slightly more transparent. Needs to match more. So you can kind of see its eyes in there. Not fully. Okay, right there. Wait, go back. And I lost it. Ah, dang it. Okay. Okay. Cell 1021. Okay. Another 1021. There we go. So now we have a back. And I'm thinking we should get a front. I mean a top. Go. That. Swap. That. And wrong color. So wrong layer. Hold on, I'm gonna have to. How wide's our boy here? 5, 26, 21. Pixels long. Oh, go away, him Kardashian. I can't see thy numbers. So 5, 6. Center that. Big. Get the swap again. I'm gonna take eyes. Like that. I think that looks pretty good for like a above view of the slime. Not bad. Now let's make it move. So duplicate. So see, slime moves. It's kind of like alert forward. So you get a little fatter in the front and thinner in the back, but longer. So let's go here. So nope. Got to do it again. Okay, so it's a little fatter in the front. He still needs to be round though, so maybe. Yeah, that's much better. Wait, no. Go back. There we go. Q, no. U, so we get both sides. Using the double. Why aren't these moving? It'd be funny if his eyes went a little cross-eyed, because he's getting stretched. So maybe we can do like a slight, like one eye goes this way, one eye goes this way. That'd be kind of fun. So I'm gonna leave the original eyes there for now, just so I can use them as a reference. Up, I used the wrong. This is the eye color. Oops. Back. That. And we get to do it all again. Okay. More. Here. Yeah, like that. So you can see his eyes get pulled to the side a little bit when he moves forward. Okay. So there you go. Flip. 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 There we go. So that's forward movement. A bit of idle action there. Forward. Side. It looks like he's getting bigger and not moving. So let's There we go. Well, yeah, I like the eyes separating. Okay, so that's the top one. Ooh, that's gonna require a whole different rotation to do, but okay. I guess maybe. Oh well. Okay, so right. Let's see.
Animations of our enemy. Okay, so after we set the relative rotation of our enemy to minus 90 degrees, this means our enemy is facing forwards, and so we'll make our flipbook play the forward flipbook. To do that, just drag in the paper flipbook, and just drag off here and look for set flipbook, and then the flipbook will set it to, if we just drag in the flipbook idles that we made, and just drag off here and look for get a copy, and for the number, just leave this at 0, because for our flipbook idle, let me just compile this again. For our 0 number, that is where we play our flamethrower idle forward animation.
Okay.
Just connect the nodes here. And then I'm just gonna copy and paste this 7 more times.
Oh, yeah.
Okay, for the second one, we want this to have a Z of 45, and you just want to call this front right, and make this have a value of 1. For the third one, we want this to have a value of 180 degrees in the Z-axis, and we just want to call this left, and we want this to have a value of 2. For the fourth one, we want this to have a value of 135, and we just want to call this back left, and we want this to have a value of 3. For the fifth one, we want this to have a value of 90 degrees, and we want to call this back, and we want this to have a value of 4. For the sixth one, we want this to call this, I did all the click somewhere and connect this equal sign into here. For the second one, we want to connect this to the fourth one here, so I'm actually just going to select all these nodes and move them up a bit, and we just want to connect this one into it to the, for this first one here bottom, and one here to have an 8 directional. I can see my enemy's left sprite. If say I go here, I see its front right sprite. If say I go here, I see its front sprite. If I go here, I see its front left sprite. I see its right sprite. I see
Problem is, this is gonna. So I want to get up to like 1,000 enemies, right? This much constant checking, I feel, is gonna slow it down. I could make it so that within a certain, say the player has a certain range that is built into the player, that when an enemy enters it, it activates this code. So at max, you'd only maybe have, like, when everything gets cluttered, maybe 250 enemies, all checking, and, you know, doing their updates, which might work with this system. Or we go with a 2 flipbook system, completely abandon the git rotation. Rotation only need to be updated once. Okay, so this is hurting my brain. Like, it's making sense, but it's also not when I try to think about it. Okay. So let's take this, just kind of do some experiments. So export. Then make new folder. Slime or enemies. Okay. Here. Pull up. Sprite. Pull that in there. Then we gotta, of course, gotta do the fixes on them. What did I just do? Open. User to user interface, and then filter to nearest. Okay. Good. And we can extract sprites. Grid 32 by 32. Extract. These empty ones. Okay. Now I have to get better at making like name conventions. Naming conventions. Let's start with the back. So create flipbook. Slime underscore let's see, move back. Okay. Then this one. Create flipbook. Slime underscore move forward. Slime underscore move right. Slime underscore move left. Slime underscore move top. Okay, then we're gonna take you, and you. To create slime underscore idle forward. Okay. I want you to go here. Man, is this numbering thing a pain? Okay. Oh, looks like I finally moved though. Okay. So I want him to look. Go back for a little bit. The first one, yeah, the first one isn't lasting long enough, so. What got messed up? Something just moved. There we go. That one's good. Okay, so 15 frames. Sometimes the undo button just does not work. Oh, why are you blurry? Why are you suddenly blurry? You should not be. Why are you blurry? Now you're blurry. What's going on? And they're blurry again. What the heck? Why is it... They just reset. Well, all that needs to be scrapped now, because it's... Wait, are you gonna... Okay, they update. Whew. That's a relief. Okay, so 8 frames for the first one. Is that what I did for this one too? Yes, I think 6 looks better. 6 and 15. So 6:15 ratio. Okay, next one. 6. Nailed it. Six. 15. So idle, back forward, back move, forward, side, top. Okay. So now let's... It'd be great if you actually let me like scroll up. Open you. Oh boy. I gotta love it when Unreal just crashes because you moved a file. I don't know what's wrong with collision profile. Like, that's an error I get every time. Where are all the sprites? Why? Just why? 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 You don't have to be this way. You could just, work. You don't have to be this way. 32 by 32. Delete, yes, delete, yes. Okay, so idle. It broke all the animations. Okay, now I just have to reopen them. Okay. So go back in here. Open this. Yeah, it even broke that. So we're gonna take you. Oh wait, how do you make? Okay. This is harder than I thought. Slime. Idle, right. Slime. Left. Slime. Idle. Back. Slime. Idle. Top. Okay, so here's all the idols.
Idle. For one, we want this to. I made sure everything. We want to connect this to the fourth one here. The very end is the front left one. That's right. I see it's back right's right, and then I see it's back's right. So pretty cool. We can have an.
Okay. Not what I clicked, like, remotely, but... Okay. Again, not what I'm clicking, so please stop doing that. Much obliged. Okay, so this is getting the character vector, putting it into numbers so that it can... Okay, so what we're going to have to do is a lot. Okay. Slime idle forward. Slime idle. Slime idle back. Left, and okay.
The flipbook idols that we made, and just drag off here and look for get a copy, and for the number just leave this at 0, because for our flipbook idol, let me just compile this again. For our 0 number, that is where we play. They are flamethrower idle forward animation. Just connect the nodes here. And then I'm just gonna copy and paste this 7 more times.
Okay, so these are the checks. 2, 3, 4, 5. Okay.
Okay, for the second one, we want this to have a Z of 45, and you just want to call this front right, and make this have a value of 1. For the third one, we want this to have a value of 180 degrees on the Z-axis, and we just want to call this left, and we want this to have a value of 2. For the fourth one, we want this to have a value of 135, and we
90. 1, 2, 3. Oh, wait a second. I can probably get.
we just want to call this back left, and we want this to have a value of 3. For the fifth one, we want this to have a value of 90 degrees, and we want to call this back, and we want this to have a value of 4. For the sixth one, we want this to have a value, get to the, and move them up a bit, and 8 to the 1 at the very top. And that will just make it so the enemy is facing the correct direction depending on where the player character is. So for this first one, we want to connect this all the way to the one at the very top here, and then just double click somewhere and connect this equal sign into here. For the second one, we want to connect this to the fourth one here, so I'm actually just going to select all these nodes and move them up a bit, and we just want to connect this one into the back left one here, and again double click and connect the equal sign into here. For this third one, we want to connect it to the third one here. So just hook up from here into here, and again double click and connect.
Forward, left, right, back. Forward, back, left.
The equal sign into here. For this final one, we want to connect it to the second one here. So connect from here into here, and again just double click and connect from the equal sign into here. And for this less than sign, connect it into the one at the top here. Okay, so that's half of.
Okay. There's gotta be an easier way to do this. Get a character pin, location. This gives me the numbers. Turns it's negative or positive. It's positive. Do I even want to know what this slime guy's gonna look like? Yep, that's a problem. Why is everything broken? I have no collision anymore. The slime is gone. What the fuck? Why? Time access not trying to public health function. Get player character. From what? From where? I'm trying to read property call function. You're causing a lot of problems. You're not even in the world. How are you causing problems? I just straight up do not have collision on my character anymore, so I might have just screwed everything up somehow. What was that? Why do I fly now? Oh, wait a second. Hold on. Okay, so that's... Okay, hold on a second. Hold on. I can still... Why? Like, these are broken now, too. And the sprites are gone. Okay. This whole enemy needs to be scrapped. He is screwing with everything. Yeah, just get rid of all of it. I'm still fecking flying for some reason. Why? Okay. So it's... Yeesh, you're coming on a little... Ooh, that looks... Coming on a little strong there, Matt. Also, he's not here. It's just kind of me. So playing the actual game... Kind of like it. I like the... I did turn fog on, so I do have some limited range in my perspective. You know what? I know what. I feel like I have far more... You're the reason the village had to kill the other villager? Oh, jeez. Streamlabs was not happy. For the record, if you're referring to mine colonies, I'll have you know Herobrine corrupted him and then they fought and died, so... You know, nothing I can really do when I've angered a god accidentally, if it just so happens to attack a villager village. Okay, so it's... Oh, I'm actually in the game. Oh, and I'm glowing like a god. Cool. Okay. So this level in active editor. Okay, there we go. I think it's back to where it was. All your fault. Nah, I blame Herobrine. There is no blame upon me. Okay, how do we want to... I gotta think about how the logic of this works, because so I now have a system that can get the slime's current position compared to me. Problem is that's kind of like a high resource value if every 1,000 slimes, or every enemy and every player and every player, every NPC is looking for my position on every tick. That's gonna cause a problem, I think. I think I need to find a way to limit that. Like, it's just kind of breaking my stuff. It seems like we're able to at least get in again and actually play. So that problem's fixed, partially. No, stop. Go away. Hold on, let's see. I need where? Do I have it on here? I do not. Okay, we're gonna have to do this in Clip Studio Paint. Give me a second. Okay. So we're gonna have to, like, logic draw this out. So we have a slime here. Oop, there he is. Okay. So let's make the player... Oh, hold on. Okay. So if rotation... Oh, dude, use blue for directions. So if directions... Hold on, I think I'm saying right. So this way is 0. So that's forward. So put an arrow here. Okay. So the changes that I would need would be here, 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 and then just like the reverse of this. This would be front, this would be right, this would be back, this would be left. Hello, Cynthia. Welcome to the stream. All right. So that. Oh yes, circle drawing, trying to analyze AI components. Very entertaining. Hey, welcome to the stream, though. I hope you can enjoy. I don't suppose you know how to make sprite characters low resource change, do ya? Trying to figure out how to make. Hold on, let me show them off. So I got this little. Let me find them again. So I got this little bugger here. Ooh, he currently has 2 sprite sheets around him, and he needs to be 1 sprite sheet that changes. Where did you go? Come here, you. Get over here. Stop. Yeah, you stay there. So we're working on getting him to be directional, bigger, change on certain situations. So currently, yeah, he does have a move animation. It's a little choppy though. He doesn't quite turn fast enough. As you can see, the sprite twists, which I know how to fix that. Well, know how. I know a concept of how to fix that. I don't know how to fix that. Essentially, if I can get back to my drawing software. So this will determine if it's a front-facing sprite, left, right, or back-facing sprite, and there's also one on the top. They'll have to get the player's position height-wise. So there's a few ways we can do this. We can either do it through constant checks from the slime, who's like, "Hey, are you near me?" And the player's like, let's see what's the color I haven't used. Let's use yellow. So the player's like over here. He's all cool and has a sword. I'm still new to Unreal Engine. You are much further along. I don't feel much further along. I'm barely scrapping up this whole project together. Alright, so we got our player here. And essentially, we can either do it... A system that I think might run a little bit faster is if we go with a... How long have you put into it? About a month. Like, many hours? 20? Maybe? Maybe more, because I have shuffled around, and I've had to delete entire projects and start over again, so... But as I was saying, so I can either do it a system where the player has this little bubble of influence, where any, if there's any slimes in here, they'll be the only ones getting the updates. And then they'll start running the, oh, look towards player. And then... all the ones out here will just be stock still either sprites. So they won't even render anything. They'll barely even have anything. I think that might be the best system to go with in terms of detection. Because rather than having 1,000 slimes going, hey, 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 I see you, I see you, I see you, I see you, it's one character going, oh, I see 3 slimes. Blueprint is what I'm currently going with. Where did I save my game? AI logic. Save this. Okay. So yeah, I think if we go detection this way, it'll be less intensive. And then in terms of slime, like in terms of switching, so I was actually using this tutorial over here. I mean, just watch tutorials. If like I'm not that far ahead, just because I've just been watching stuff like this. There's some pretty good tutorials out there. Yeah, so his system was to have it call the player's position and the enemy's position at all times, and then adjust the sprite accordingly. Which tutorials have you liked? I've really liked See, he doesn't even really... If you want to understand game development, like the concept of it, I really like... here, let me pull up his... He's the guy I've been watching, like, I spend hours watching. Let's see if I can find him. History... Don't. No, I don't want the Jenny mod videos. Go away. I'm looking for good content here. Okay, it should be... Man, I could have sworn I watched him recently. Nope. Wrong guy. Wrong guy. Oh yeah, dear YouTube, stop slowing down, please. You're getting slower and slower every day on every single device I have. Heresy, Reddit stories. Here we go. His name is Thomas Brush. So he made a few games and he's pretty successful. He doesn't teach you how to make a game. He teaches you how to be in the mindset of making a game, like everything you have to do, how to get published, stuff like that, and like workflows. So I like that kind of stuff. So Thomas Brush. Then, as for like every other thing, I just jump around because no one's gonna have a tutorial. Well, Thomas Brush said this. No one's gonna have a tutorial to how to make your game. There's gonna be thousands and thousands of tutorials you're gonna have to go through to get aspects of, to copy, and then change into how you want. Which is what I'm doing right now. I'm taking that other tutorial and trying to convert it in a way that will work with having 1,000 slimes. Speaking of, I kind of want to go say hi to the 1,000 slimes real quick. Which one was it? This one? Oh yeah, so like he's really good. I like his stuff. Okay. Oh. There's my head. There's my body. Oh, there they are. Definitely getting... So this is a test world I made to see how many slimes or enemies it can handle. So this is 1,000 enemies. Oh, whoa. Yeah, so ideally, this is about the number of enemies I want in the game. Almost for every big battle, so about 1,000. And, so, I mean, it runs decently well. I mean, I haven't optimized anything yet. This is just pure raw, find me, attack me stuff, like... I love seeing them just fall from the sky. The current problem is like they forget where I am very quickly. Some do a pretty good job at staying near me. Hello, my little children. Alright, so there's that. I just like doing that because it's just fun. But in the open world section of the game, oh, is it this one? Yeah. Testing open world. I think it's this one. Yeah, so in this one... Oh, this is why I added the sound. Okay. Yeah, so I started playing around with sounds, so just some ambient wind and birds chirping. Let me just jump up onto this wall. Alright, so yeah, I'm just working on... trying to see what biomes are gonna look like. So what's your idea for your game? So it's, have you ever seen Mine Colonies? If you haven't, check out my other videos, because it's a Minecraft mod I play a ton. Where it's, you just build, you manage like a colony, or like a city, and you upgrade everything slowly over time. Buildings are built in real time, and you have to collect all these resources to, like physical resources to make the city. Then you get NPCs that go around and do all this stuff for you. I'm like, wow, this is such a fun mod. I wish it was just like its own game. And now I was like, well, why don't I do it? And then, a month later, here I am. So yeah, it's gonna be a medieval city builder with dungeon crawling aspects and high tier magic. That is like my key catching thing of what I want. I want magic that just blows up a city. And so yeah. And then everything is going to be very simple. Because I don't know why, like, I don't know if you've ever played, like, Final Fantasy or JRPGs, like the old ones, pixelated. I just love that art style, but I love 3D games, so this, the art, is me trying to make that into 3D. So, look at him from the front, he kind of just looks like an average, you know, RPG Maker character sprite. But by adding multiple sprites to him, you can see him from different directions and it makes him 3D. Then same for the buildings, I kind of want to do that. Well, the buildings will actually change and shape, depending on how you look at them. Or I might just, you know, go simple and, you know, make it an actual physical building like this. And all the trees will be like this too. So yeah, I want to have big battles defending your kingdom. Then, let's see if I remember where it is. And then there's gonna be words. And then the concept of like how you're gonna upgrade stuff will depend on your style. Like, do you want to train them through like the barracks, or I have this idea for which I don't know if I'll ever get to plot. I do have an idea of a plot, but I don't know if I'll ever follow through with it. But let me run over here real quick. So across the map from where you start, there's gonna be. I can't run too fast because I lag out the game if I do. Here we go. Okay, so there's gonna be a giant dungeon. That's gonna be like the challenging bosses of the game. There's gonna be multiple smaller dungeons too that the player will be able to access, but this is like the dungeon. And each level you go up, you get higher and higher rewards. And then the system I want to implement is you can send your troops there to train. So you have a higher risk of losing them, but you have faster experience gain and other stuff. But that's like very far-flung content where I'm like, I don't even know if I even do that. But if we go back over to the city real quick. Well, also need to increase jump height. That's gonna be my favorite aspect of this game, though, is just the sheer speed the character runs at. Like, I'm not joking. Like, oh, hello. Hey, thanks for the follow. Hope you enjoy the jiggle physics. All right. Yeah. So for me, when I play Mine Colonies, I have special Minecraft armor that just makes me incredibly fast. But it's not fast enough because I'm always running like, oh, I gotta give this guy his paper. I've got to give this guy this thing. Ah, I'm glad you like him. And so, as I say, like I'm just running back and forth supplying all my people. But I'm like, man, I wish I could just run faster. And so, the initial concept of the game was, well, why just make a mod that makes me run faster? And then that spiraled out of control into, I can make a game! And now here I am. So yeah, I want to have just the player move ridiculously fast. Like you can move and then get some airtime, and then I want to implement it into combat where the faster you run, the harder you hit, and then there's going to be a whole different magic system and how all that comes into play. But yeah, so just, that's... Okay, let's see if I can remember. So the hook, or the basic summary of the game is Doom, but city builder, is what I'm going for. So like very, like old Doom graphic looks, but in like an open world, and you're building a city. Yep. Here. So yeah, that is the idea. It is, I think it is a good idea. Very, very idea-like. Now we're just going through now we're just like in the very, very basics of trying to make some enemies. So first basic enemy the player's going to come across is this cave slime that glows in the dark, which I think is really cool. This is more advanced. Then we'll have, skeleton boys. And then, golem knights. So yeah, so I kind of rambled on and on for a bit, but, I'm trying to, explain it, but I'm also trying to figure out, hello. Go away. Go away. Yeah, I mean, see, I just ran a good distance, but he still follows me, so. Whoop. Whoop. Dang, why is this guy so good? Okay, I think I lost him. My favorite thing I've coded so far is, watch this. He randomly roams. A second. Whoop. I love that. I love AI. It's so cool when you get to do stuff. Yeah, and this is me testing out just like what a city would look like. I only have one building so far, which is just the basic. Like, this would probably be like a max level house, I think, because of how big it is. These are kind of like what the houses would be like. You'd line them up, and citizens would live in them, and, you know, do peasant stuff. Like, pay me taxes or something. Oh, yeah, so on the side here, so the magic system is actually based off my... Oh, actually not mine, but like, yeah, mine. But based off multiple of my comics, where there's going to be... Let's see, one, two, three, four... Oh, why can't I count? I am tired. 1, 2, 3, 4, 5. So there's 5 different types of magic you can use. 4 of them are actual combat. And then well, 4 of them are actual magic types. And then the 5th one is like a booster magic, where you can do more intensive... you can boost the other 4 magics by using your yellow. And so that will affect how things go. And, just to give you an example of just how big I want my magic to be, let me give you an example. That in. So this is just... Whoa, whoa, whoa. So yeah, I mean, like, I want big magic in this game. I don't think that's even big enough. I need to make it, like, bigger and more detailed. Yeah, so magic circles are going to be like a timed thing, so you can't just go fireball. It's going to be more of a, oh, I have to make a circle first, and then I can go fireball. But you're trading time for damage, essentially. So it gets bigger, and yeah, so that's kind of... That's the idea. Big freaking magic. Just coming out and just wow, 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 and everyone's dead. Then I want to have, you know, like, of course I want to counter magics too. That, like, giant city shields will be a thing. They're kind of like, the shield magic will actually be kind of used, kind of similar to, like, Minecraft torches, because there's going to be mob spawns in the dark, because I just like that system. So I'm like, okay, but how would you keep them out? So it's like, oh, shitty shields, because those are always in stories and stuff, so... Yep. That is the gist of it. Questions, comments, concerns, as my history teacher would say. So where did I put the tutorial? Here it is. So we still have to figure out, though, back on the tangent before. So I say we definitely go with this. The player checks for stuff. And then when it finds it, it sends a message to the things inside, like, hey, I see you, you're in my range, start updating your sprites. And then they go, oh, okay, and then they start updating the sprites depending on where I look. Now, okay, so we figured that out. That's set in stone. Now we gotta figure out how to adjust the sprites. So we got the rotational detection. I'm honestly debating... So if I have get rotation, okay, blah 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 blah. Okay, so if I have a blueprint that says get rotation, or you know the part that we have, it goes over and then it tells the sprite which one it should be. I need to logic that out, I think, later. My brain, it hurt. Okay, so let's do a... My problem... Ooh, excuse me. The problem is... I cannot tell... Well, the tutorial does not tell me how to update when moving. Which is a key to figuring stuff out. What is this tutorial?
In our levels, we're gonna base everything else off floor, so from underneath, we need to go in. So the first one, movement, we want a
Gameplay abilities, enemy setup. What does this guy have to say?
second. And then I'm going to split this return value where it splits the struct into X, Y, and Z. And then from Z, I'm going to subtract. And I'm subtracting 90 so it faces the player. And then all I'm going to do is less
Oh, it's hurting my brain.
and down. So it would appear that this is working indeed. Which
Holy
is pretty
cow.
cool.
This guy's already got it going. Yeah, we might have to check this guy out then.
Next, we're going to go back and change its scale to be 2. Cool. And then back to testing, it is going to still be on the ground, which is what we're looking for. Cool. And of course, if you shoot it, nothing's going to happen, so don't try. Next, we're going to go back into the enemy, and we're going to switch over to the event graph, because what we need to do is figure out how the sprite will always face the player. And we've done this already with the weapon, but this one's going to be a little more complicated, because when the character is walking around, the sprite still needs to face the player. However, depending on the direction the enemy's moving, we need to see a certain angle of the enemy as they move away or towards you or whatever, but still facing the player at all times. So let's figure that out. First thing I want to do is create a macro, and I'm going to call this Sprite Face Player.
It's a macro.
And in here, it's just going to be kind of what we did before, so I'm just going to add the in and out exec pins real quick. So the first thing I'm going to do is get the player camera manager, and then from that, I'm going to get the camera location. And then what I want to do is grab this enemy footbook, because we need to get its world location. And then we need to drag out from the return value, and we're going to find the look rotation, and the target is going to be the camera. And then I'm going to split this return value where it splits the struct into X, Y, and Z. And then from Z, I'm going to subtract. And I'm subtracting 90 so it faces the player. And then all I'm going to do is from the enemy footbook, I'm going to drag out and say set world rotation. And then all we're setting the rotation to is, well, we're splitting the struct because we need just the Z. So the Z is the only thing that's going to be rotating. And then you hook up to the out, and that should be all we need. So now in the event graph, you need to put that right after tick. And then compile and save, and we can actually play this, and you'll see the sprite is facing the player. Back in the enemy blueprint, I went ahead.
So, let's try... Let me go into the player real quick. Edit first person, okay. So we're going to go in here. Add a cylinder. We set to update sprites. Oh, yeah, it's the name. So update sprites. Okay. And we're gonna pull this down a little bit. hit on component. Again, overlap. Hide. Okay, that's not working. Just get rid of that. With a sphere instead. Okay, so it doesn't have any collision. Good. Okay, so see, event called when something starts to overlap this component. For example, a player walking into a trigger for events. Objects have blocking collision. For example, a player hitting a wall. See hit event. Wake up on go to sleep. Feelings changed. Clicked. Released. On component being overlapped. Other actor. Yeah, that's gonna be a lot of research I'm gonna have to do into that. How can I give you like a tag or something? Mesh component status, component tag, character movement, capsule component. Actor? Yeah. Not more needler. Okay. Alright, hold on. Let me do this. So we go. If there's a perfect number of items here, you can't add anything new. Like, it just doesn't let you. It's too... How... So ridiculous. I can't... Drag that back. Sprite, move here. Rename to enemies. Okay. Slime 1. Okay, now we're gonna go into here. Open it up again, fix it. User interface, filter, change that to nearest so it doesn't get all blurry. Save. There we go. Sprite. Grid. 32. 32. Extract. Delete these empty ones. Okay. always fun going back, doing all your work over again. Okay, and I want to create blueprint. Character. Slime _1. Okay. I'm gonna grab a book. Okay, give you forward. Let's see. Slime _1. Idle forward. Duplicate. Just extend all these. Okay. Go back into Slimy Boy. Okay. So kind of going back to the start with this a little bit. Let's see. There we go. He's about the right size. Basic. Oh, hello. Did I lose him? He's bobbing and weaving. I think we lost him. He's a very determined little bugger. Give him that. You can't. Oh, there you go. Did you make it? Oh. Let's see if we can get him to go off the edge. Oh, nope, his AI broke. Shame. Alright, so we got a basic UI working again. Okay. So. Let's follow this guy's tutorial and see.
And I added footbook variables for each direction that the enemy can face. So I made one for front, left, back,
Yeah.
left, back, right,
Right.
front, right.
My legs
And then
can't
I
take
put
any
them in a
more standing
category,
today.
Called footbooks, and I made sure to make each of these public variables
lower down,
so that they can be changed in any sort of blueprint that will inherit from this. Now I want to make another
There we
macro
go.
that I'm going to call get enemy angle. Next, now the what we're doing basically here is we're saying we're adding angle personal materials. So now the character, you can see he's facing to the right, and I keep moving, and he's continuing to face that direction.
Okay.
So it would appear that this is working indeed, which is a
Alright, I think we have to do more research on that. for now, I think I'm actually going to swap over to mine colonies. Just for a bit, just so we can get the conclusion of finishing our town hall.
Oh no, you didn't. Payback is a coming, you will be running forever. Oh no, you didn't. Until I get my vengeance, I will never end this mayhem. Oh no, you didn't. I'm a mercenary, you ain't got a prayer, you owe me. Oh,